Okay, sure. Good evening. There's evidence existed to say that there are some. They are not there. Yeah, mind. Right. First thing that there's some from our students. Are you going to do the in-class exam today? And because you are going to have an additional class tomorrow, so and there's request whether you can have it tomorrow while being at the home. What do you want? Okay. Also, you can come up. So I'm ready to do it today. Do you want this to do it in the class or tomorrow while being at the home to do that? What do you want? Come on. Okay. So, because of the request of the majority, right? I was planning to have it today, but again, student came and told that there's rural and issues. But on the other hand, I would like to ask you, majority, and anyone who wants to do it today? Okay. So, you can be at home, and the other thing which I would like to make it tomorrow, because of the availability of the computers. I don't see some people are having trouble. Okay. Again, I think some people came after this significant number. So we'll ask them also whether you want to have it today. So there's a thing, material infusion into the class. Material infusion to the class. So I would like to ask that, okay, today I was planning to have the assessment as I told you, but then certain students raised certain concerns, and because some students don't have computers, there at the moment. So, so to conduct it tomorrow, right? And afterward, it's an in-class assignment, which you can do it today or tomorrow. There's no any problem, right? So, I would like to listen to the majority. So, what do you say? Shall we have it tomorrow while being at home? Today? Today? Let's take a watch. After all, please do understand. I have the right to do it anytime I want. Right? I have the right to do it anytime I want. Because why? Because it's an in-class assignment. So I can do it today or tomorrow. Right? So therefore, it's not that it's an exam that you have to pre-announce. It's a classroom assignment. Right? So kindly to understand that that's it. If not, there will be again a lot of legal issues. Simply on the way. Other person, no, I can do it anytime. I have the right to do that because I'm the lecturer of this class. Very kindly I'm informed because not having misunderstanding. So therefore, I would like to hear to the majority, right? And even I can do it today or tomorrow, right? I'm going to do that. But then the students who are requesting tomorrow are telling that they don't have computers at hand, some people, and also some other issues are taking place, right? So can you raise your hands that you could do it tomorrow? Okay, today. Today. So we have half off. So I cannot do that. You have to tell me by deciding. Right? You have to tell me by deciding. So I'll be fine to decide. Right? Because I cannot have half off. But again, you understand I have the right to do it anytime I want. Right? I reserve that right. And it's an in-class assignment, and we are supposed to have in-class assignments every day, regardless it's a physical class or an online class. So I reserve that right this morning. Right? But again, I'm doing that to you because I like to give you the chance to do that. So therefore, I would encourage the batch leaders to take a vote. Right? Okay, batch leaders of which batch is covered. Right? And based on that, we'll decide. Based on that, we'll decide. Because I need some kind of a majority to get that decision. So two batch leaders are there. I think we have one batch leader. So we'll take the decision based on statistics. So the two batch leaders, please have a poll, right? Created. Whether we are going to have it today or tomorrow. But on the other hand, please kindly understand, I have the right to do it anytime I want, even at the moment. Now, I can do it. It's a classroom, in-class assignment, and I'm supposed to do in-class assignment in every class. Regardless, if you have so, the batch leaders, please have a WhatsApp call and tell me. I will give you some time. We have till 6:30 minutes. So please inform me. And so we agree what the majority says. Okay. The majority wants it now. So, will you likewise? Okay, while we are having the poll, right, while the batch leaders are conducting the poll, we'll continue what we were discussing, and then later on we decide whether we are going to do the poll. For example. Right, however. So what we were discussing, did we discuss? Regression analysis, right? We were discussing regression analysis. So let's go to the regression analysis. Correct. Right. Now let us look at right. So I hope the poll is being conducted. So vote for your idea, whether today or tomorrow. I don't mind. Like whenever, whatever the day, but again, please vote and express your willing. And we take the decision based on data. Data. Right. So let me again remind you what we were doing. And up to now, we were discussing SPSS-based data analysis. And in SPSS-based data analysis, we were discussing several things. And also, I encourage you students to come forward. Why are you packed? Packed on me. What is the next slide? So, we don't want to. Right. Again, to remind you why we do different kind of analysis. Now, what are the types of analysis we have discussed up to now? Descriptive analysis. So, why do we do descriptive analysis? By the way, Why do we do descriptive analysis? To describe the sample. To describe the sample, but the data what we have collected, because we have to tell the people who are going to consume our analysis, people who are going to read our analysis, we need to tell them what's the sample. If not, we are not telling the whole truth. Right. So that was the purpose. Yes, the first analysis that we discussed was about descriptive analysis. Then correlation analysis. Why do we do correlation analysis? To see the association or the relationship between two variables. So we discussed that the association between two variables. We discussed about that. That is related to correlation analysis. Then after that, we discussed what? The regression analysis. The regression analysis. Why we do regression? As a mean of prediction, or to see the impact. To see the impact of one variable or multiple variables over. And that's where we started, and now we are discussing certain things over there. Right. So I told you that there are two kinds of regression. What are the two kinds of regression? Simple regression and multiple regression or multivariate regression. In a simple regression, what do you have? In a simple regression, what do you have? One independent and one dependent variable. Right? One independent and one dependent. So that's a simple regression. But on the other hand, we have what? Multiple regressions as well. Multiple regressions as well. In a multiple regression, you have more than one independent variable. Right? More than one independent variable. Right. So that's where we discussed, and we even did a prediction of what? What did we predict last time? What did we predict? Who got the predicted? What did we predict? Computer programmers. We predicted the computer programmers. So that's what we were discussing. And which we had a very productive discussion on that aspect. Prediction production. Okay. Today I'm going to tell you how we can introduce a nominal qualitative variable into the regression analysis. Can you give me an example for a nominal qualitative variable? How about gender? Is a qualitative variable? Is a nominal variable? Yes. Gender, does it have an odd? Like male, number one, female. I should be crazy to tell that. It's very discriminated. Right? You cannot have an odd as one and two. You can just classify. You can classify. That's what we call nominal variable. That's what we call nominal. Religious affiliation. We have different religions, mainstream religions in Sri Lanka as well as in this world. Religious affiliation. It's what? A nominal variable. Can you say this particular religion is number one? Number two, number three. Yes, you might say your religion is number one. But others also can say. So therefore, no, we cannot have an order. It's not ordinal, it's not interval, it's not a ratio level. So it's again a nominal or a categorical variable. A nominal or a categorical. So these are called quantitative variables or nominal variables. Now let's see how to introduce such a variable into the regression analysis. Now let's see how to introduce such a nominal variable into your regression analysis. Like gender. Now here we will take the example of whether the computer programmer has a professional association or not. Right? The prediction might be if you are having a professional membership in an association, professional association, your salary might be high. Or it might be a significant predictor as well. Is it? So here it's a nominal variable because what? It's again just a no. Having the membership or no membership. If we apply that to our context, let's say you have the membership, you are a member of Chartered Accountants of Sri Lanka. Right? Whether it could increase the salary or whether it could predict a higher salary or not is our question. Again, it's a nominal variable. Having membership, no membership. Right? Having membership, no membership. Right. Having membership, no membership. Likewise, we'll have to see. So these are significant predictors, and we can see whether we are going to, how we are going to. So today, likewise, what we'll do is we'll see how to introduce nominal variables or qualitative variables as they call it. So these what we did last time. Gender male, female, as you can see, gender female. And so having membership, no membership, those are called what? Categorical variables, nominal variables, so qualitative variables, like gender, gender, things like that. Some people call these variables dummy variables. Dummy variables, not a good term, but again they call it dummy variables, or they call it an indicator variable. An indicator variable. So in this case, like now for example, if we take gender, gender is again a qualitative or a nominal variable. So in that case, we can call it as a dummy or an indicator variable as. So let's see today how we could introduce these kind of variables into our analysis of regression. So that's what we are trying to do. So we can code now. Dummy variables are coded as 0 and 1. Right, 0 and 1. So that's how we code dummy variables 0 and 1. We have two positions. We have more than two positions, then there is differently, but we talk about that later. Right. Now let's extend our example. We have membership or no membership. Whether the computer programmer has a membership, right, in an IT professional body or not. Now, what are the IT professional bodies that you know? That there are different bodies, of course. You might have ACS or BCS. ACS is what? American Computer Society. ACS and BCS, the British Computer Society. Likewise, you might the programmers might have certain associations. So now you can see that there are three predictors. What are three predictors? The experience level, the aptitude marks, and whether having a membership or no membership. So whether having membership or no membership is a predictor variable, it's an indicator variable, right, or a dummy variable, right? So being a dummy variable, we code it as what? 0, 1. Maybe no membership, we'll say 0. Maybe having membership, we can call it 1. Or if you want the other way around, you code it as there's no info. But now let's see, and then let's see how to introduce this variable into your equation of regression and perform a regression analysis. So now we have these predictors. We have three predictors. X1 years of experience. X2 is what? Marks that you got for the aptitude test. X3 is the dummy variable. 0 if individual does not have a membership, and 1 if it does have membership. Now, if you wanted to introduce gender into this equation, gender is not a variable here, but let's say if you want to introduce gender, that's a qualitative nominal variable. How can you introduce it? 0? Then you can say 0. Yes, 1, 4, 5, 6. There is no any order. 0 and 1. If you have two positions, if you have three positions, then it gets a bit complicated. Let's not touch upon that. They have two positions. Gender and having professional membership or no membership. Can we check that how to do that? Now let's see how to do the coding as well as how to do that. How to introduce this kind of analysis in the regression or the equation model. So it's very simple. Right? You make it 0 and 1. Okay. So now let's open again the salary.sav file. So let's go there. Session 4, Seller. Question for seller. Question for seller, please open that file. How's the voting going on? You're not voting. Very good. So within 5 minutes, let's finish the voting. So please vote for your preference, whether you are looking at the class assessment today or tomorrow. Right? And please tell me the answer as soon as possible. Yeah, go. Yeah, what do you have? Good. Go with them. Oh, so I would like to, because I have the right to, again to tell you that I have the right to do it anytime, but again, I'm just giving you the chance. Just give you the chance because there were some concerns of certain students. And also, laptops is a problem. Right. Answer good. That's what I really. Oh, the answer. 5 minutes more, and we'll take the decision. Because always I like to take decisions. Okay. But on the other hand, we'll discuss the other hand. Yeah. Okay. So open this SPSS file, right? Open this SPSS file. Ready. Okay, 5 minutes are gone. So let's take the result. So out of how much? Okay. Actually, tomorrow 80. This is obvious. But again, let's be fair of our dealing. So we'll do it tomorrow. But if there are students who cannot come tomorrow, I'll give it another option. Right. So whatever. Of course, it's okay. So that's what I was really wondering why these people are not taking tomorrow. Today I can do that. I'm very much ready. It's for me to do it today and finish off that from my part again. I see some concerns that students get hopefully. So that's why. Are there any students who cannot make it tomorrow? Please raise your hands. Come on. 8:30 to 12. Please raise your hands who cannot absolutely. I have a valid reason for that. I'll be asking the valid reason and you have to check about it. Of course, that's transparency, that's accountability. We're not here to. Okay, anyone who cannot do it tomorrow can raise your hand. Right, you don't need to. Please give me your information. I will make an alternative arrangement. But you have to tell it with a validation and outcome validation. So the other might be that they need to wait for it. So we'll consider it. If it is difficult tomorrow, please let me know. Like only one student raise their hand. Anyone else? You can raise your hands. It is not possible to. So that's a very valid reason. So that's it. So what we'll do is I will make an alternative for it.
He'll decide that particular. Maybe for the same assessment something. Right? So we'll discuss that and I'll let you. I will be there. If someone else is also having a problem, please let me know and I will try to make an alternative. But not for only one person. Again, I would ask it. Anyone who cannot take the vote? Absolutely. No, she cannot do that because she has an exam. And indeed, she told that she'll be showing me the admission for that exam as evidence. I will see it. So she told that she'll be showing me. So therefore, I'm going to give an exception for it. But with all due respect, indeed, if anyone is having a problem, please let me know. I will make an exception. But you have to provide with evidence, and you have to tell it today itself. Then only I can make an order. Only one student is telling that's perfect. Anyone else? Anyone online? Yes, there's online. There's one student as well who has raised the hand. Sudha, can you speak out, please? What's your good name, please? It's Fernando, I believe.
Yes, sir, it's Fernando. Yes, sir.
Tomorrow, not possible for you?
Yes, sir, actually, it's not possible.
No, there's so online there's one person who is not possible, 55 Fernando. Well understood, Sudha, there's no problem. I'll make an alternative for you.
Thank you very much, sir.
You should all no, you don't need to tell that public. Public area, don't right? So 55 is well understood, right? No. Or Sudha, you can lower your hand. Because I try to be very fair, right? Try to be very fair in the debate. Right. You my sympathy, sir. Okay. Right. For two students, I will make an exception because two students told that they are an issue. For those two, I will make an exception and we'll try to see an audit. Right? Well understood. No. I have to be very clear. Although I have the right to do it at any time, but again, rights are there. But I have to exercise that in a very humanistic way. A very humanistic way. I don't want to anyone to be inconvenienced because of an unavoidable reason like that. Why should I? Okay. Right. So what we shall do is now let's see. Let's open that salary.snd file. So that's what. Okay, go to the upper take open it. So right now the lecture is You should be resourceful always. Now, this is another way that you can learn how to open an SPSS file another way, right? One, if you have installed SPSS in your system, you can double click and open them. That's very important. Or what you can do is you can open SPSS and you can go to the location where the file is and open it from there. Just like in Excel. You can just click an Excel file and open it, or you can open Excel and open that file after that. Right? So in my case now, although I click that it's not, so I'll open SPSS and open that file. So you open SPSS and after that, how to open the file? You go to file. That means SPSS open open. You go to file, you go to open, you go to data. And thereafter, you will have to go to the location where the file is. My case, it's there. So this is the file. Session for salary of the same time. So it opened the file. Now this file is not new for you. This file we opened last time as well. But now let's look at this membership thing. Now it says ACS membership, American Computer Society membership. So you can see that there's a variable called ACS member. ACS membership. Membership ACS membership. Now go to the data view and you can see the ACS membership is there. And it has just typed yes and no. I mean the membership, no membership. Yes and no. Then I told you, it is not going to help. Can we introduce yes and no type of variable into regression equation? You can't. What you need to do is, you need to make it a dummy variable. Now, how many positions are there here? Yes and no, how many positions are there in this variable? Yes, no. In that case, you have to take one dummy variable. That's the rule. If you have 3 positions, then how many dummy variables you have to get? N minus 1. 2 minus 1. If you have 2 positions, 2 minus 1 is 1. So these are the number of dummy variables you have to create in certain circumstances. If you have 2 positions, then N minus 1, 2 minus 1 is 1. If you have 3 positions, like let's say one example, 3 regions, 4 regions, 5 regions, 6 regions, but 3 regions, then N minus 1, you have to create 2 dummy variables. Just for your information, don't worry if you do not understand. Just what you have to do is you have to create a dummy variable. How to do that? Now I'm going to show you. Already I have done that, but again I'll show you how to do that. Here membership is given as yes and no, so it has to be 0 and 1. It has to be 0 and 1. Now I'll show you. Already it's there. I have created 0 and 1. You can see there's over here 0 and 1. Can you see that? But now I'll tell you how I created that. In SPSS, there's a very strong engine for recoding. You can recode based on an existing variable. Now I'll show you how to do that step by step. How I created that. Of course, you can say, why not you look at yes, no, you put 0 and 1. Yes, you can do that for 20 computer programs. Let's say there are 500 computer programs. So I will do that manual. I don't think it's safe. On the other hand, in Excel, if you want to do that, yes, you can find and replace. You can find and replace. You can find 0 and replace it. You can find yes and replace it 1. No, you can replace it 0. But in Excel, you have 3 or 4 positions. Let's say you had 4 religions and you have one. It says one column, it says what? Buddhists, Christians, Muslims, Catholics, the Hindus, etc., etc. I'm sorry if I had missed your religion. Okay. So you had several religions on that case. In Excel, can you find and replace at once? Right. But in SPSS, right, you can do that very easily. That's what I'm going to show you. How to recode and create a new variable. Now I need to create a new variable. Like what? As what? If membership is yes, I need to make it number 1. Right? The code has to be number 1. Right? Now, for example, here it's done. I want to create this variable. Now already it's created, but again I'm going to show you how to do that. It's no, it's then it should be 0. If it is yes, I have to make it 1. There are only 20 computer programs here, so it's not a big deal here doing that. But I will show you. If you are going to do that, right, for 500 or 1000 observations, how to do that. So please take down. Please take down. Creating a new variable. 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 You can take down. Creating a new variable. Creating a new variable. Based on creating a new variable. Based on recording, based on recording, based on recording of an existing variable, of an existing variable, of an existing variable. Based on an existing variable. How to do that? It's a very simple process, but you have to anything at the beginning might be a little bit confusing, but once you see that, it might not be. So please take down the steps and please tell me whether you can, whether you have any problem. So let's see how to record. So a different way and create a new way. I have already created this membership dummy. So I'll tell you how to do it. First, you have to go to this. You have to go to transform. Please take down. Now the steps. Transform, recode into different variables. Recode into different variables. Transform, recode into different variables. Right. So then you get this usual dialog box all the time when you click anything comes in dialog box, right? That's what it is. Right. Doesn't take a problem. Right. You can see then all the variables are there. Then select the variable that you want to record. Select the variable, the existing variable. Select the existing variable you want to record. Select the existing variable you want to record. So that's ATS membership. It has yes no type of question. ACS membership. ACS membership. That's yes no question. Maybe male, female, maybe yes no. And you can put it on here. Then it says membership. That's the existing variable. And now that's the new variables name. Let's call the new variable membership dummy. Because I'm going to create a dummy variable. So I will say mem. Then underscore, because I cannot leave a space. Mem underscore. I'll say dumb. mem underscore done. Mem. There's an underscore and no spaces down. Why did I put an underscore? I could have left a space. Mom, you can put underscore space at the end. Why? In spaces, can you have spaces in names? But on the other hand, I wanted to leave a space because that's why I put an underscore so it's clear. So membership done. Good. You can do your own name, there's no problem, but just to make it clear. And then what you can do is you can click on change. Right. So it will come then. Now see here it's nothing. There is a question mark for this. Change. Membership done. Membership done. So what I'm trying to tell is, this is the existing variable, this is the new variable. The existing variable is membership, ACH membership. Then the output variable, the new variable is membership done. Now we have to give the coding scheme. The coding scheme is given like this. Now you go to old and new values. Old and new values. Old and new values. You go to old and new values. And then it asks what's the old value. Now the old value, the existing value. What are the existing values? Yes and no. Membership, having a membership is yes. And it says, you can see here, right? Membership is coded as, not coded, it's just written as yes and no. So what I'll do is, the old value, I will say, okay, let's say yes. Then what's the new value? If the old value is yes, what's the new value? 1. So type 1. So I type here 1. If the old value was yes, the new value is 1. Then I'm going to press add. Okay. I pressed add. So it says if yes, make it 1. If it is yes, make it 1. Yes. If it is yes, make it 1. Then the old value, let's say, what's the next value? Yes is there. And is value over? No. So the old value you can type here no. Give as it is in capital O simple. No. There I will say if it is no, then what's the old what should be the new value? Always remember, if 1 is 1, the other one should be in a dummy variable 0. Always it's coded 0 and 1. Make it 0. 0. If the old value was no, I'm asking to make it 0. Right. And I'll again add that, then you can see no, make it 0. Right. That's it. That's it. Now press continue. Press continue and press OK. Is it clear? Old and new values 1 and 0. And I'm going to make it OK. Is it okay to make OK? Right. It was executed. Now you can see a new variable should have come 0 and 1. So we don't need decimals. So I'll go to the variable view and you can see there's a new variable membership dummy, mem underscore dump, and I'm going to make the decimal 0. I'm going to make decimal 0 because we don't have half membership here, right? Whether you have membership or not, yeah, 50 half membership, then you can say 0 and 1. Anyone forgot stop? Puna. Make the decimal. You got the variable and make decimals of 0. How about you? Done. Yes. Okay. Oh, fine. Okay. That's how you are going to create a dummy variable if there are two persons. Now, had it been gender, male, female, you can make anything in, right? Make a male 1, female 0, or female is female 1 and male 0. There's no problem, make 0 and 1. Right? So that's how you create a dummy variable. Right? This is how you create a dummy variable. Now the next is easy thing to do a regression analysis. Now please take down. Please take down. Take down. Using the above procedure. 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 We created a dummy variable, a dummy variable, a dummy variable, a dummy variable for the membership, for the membership, for the membership. Come on, which is a nominal variable, which is a nominal variable. Membership is a nominal variable. Now we created dummy. Okay. Full stop. Then you can say, now we could introduce this dummy variable, this dummy variable to the regression equation. Now tell me how many independent variables are there? So you have what? 3 independent variables. What are 3 independent variables? Number 1, experience. Number 2, marks for the aptitude test. Number 3, membership done. Now let's try to introduce this and see how to interpret the result. So let's see how to perform the regression analysis. I can claim how to perform an OLS regression. OLS regression है how to perform करें? You go to what? Graph, right? You go to graph and you go to what? Pie chart. How do you do regression? You don't go to graph and you draw pie chart for regression. What do? You go to analyze. You go to analyze. Then go ahead. How to do a regression? I forgot. You go to analyze and then where? British. Then go where? Leave. You go to leave. You go to leave. Analyze, regression, leave. Go over there and press OK. Press on that. What's the dependent variable here? What's the dependent variable? Tell it. Tell it. Color is the dependent variable. And then what are the independent variables? There are three independent variables. One, experience, you can take the number one, experience. Second one is what? The score in the aptitude test. Now the third one is what? What's the third one? The variable you create. Done. Membership. Done. Put the dummy variable here. Mem done. Membership. And then what you have to do? Press OK. Right? So just put these three and press OK. That's what you have to do. Right. R square value is how much? R square value is how much? 0.847. How do you interpret that? R square normally interpret correct? Last time look at your notes. Don't worry. Don't be shy. Look at your notes and tell me what's R square. Don't be shy. Don't be shy. Of course, no one can remember everything. And today, district plan system, assessment. So what's R square? What's R square? R square is what? What is R square? That's the exponent power of the independent variable. How much the independent variables explain the dependent variable. Now you have three independent variables. Now last time what was the answer? If you had taken only two independent variables, the salary and the score. What was the answer? 83.4. The same regression, except that membership dummy, it was 83.4. Now introduce a new variable, membership. What has happened to R square? What is R square? It has gone slightly, it has gone. Now what will I? It's 84.7. Slightly go down. But is it a significant increase? No. Slightly, slightly it has increased by something. Then you go to ANOVA table. You go to ANOVA table. You go to the ANOVA table and you check the ANOVA table. In ANOVA table, you look at what? ANOVA table is nothing but one Antima column. What the Antima column here? The F test result. Look at the notes. There is no problem. It's not an exam. You look at the notes. You tell the two last column indicates the ANOVA results. And the last column for that is the significance of the ANOVA test. What do you say? Is it significant? So it says again 0.0000. So what can it say? Is the model valid? The overall model valid or not? It is. Because always we are looking at something less than 0.05. Last week I told you why we always look at things less than 0.05. Why is that? Because we have the more than 99% or 95%, if it is 0.05, more than 95% confidence that there is a significant impact or the valid or whatever things there. In this case, so we can conclude what? The overall model is valid. Excellent. The overall model is valid. Then you go into the coefficient table. Now comes the interesting one. Tell me what are the significant predictors? Is the experience level a significant predictor? Is the experience level a significant predictor? Coefficient table is one. Is it? The significance value is 0.001. Right? The individual significance level is less than 0.05. Isn't it? So what's a significant predictor? Yes or no? Yes. Right. On the other hand, aptitude test mask. Aptitude test mask. Right? What's that? Is it significant? Yes. Again, that's also less than 0.05. In fact, it's 0.044. Less than 0.0. Marginally, it has got a bit of 0.05. That's good. So it's a significant. But how about membership? Is it a significant predictor? Is it a significant predictor? No. It's not. Because here, see, the sig value is above 0.05. So it's not significant. It's insignificant. So if you are going to give these computer programmers some advice recommendation, what would be your recommendation? If you are going to give a recommendation to these computer programmers to increase their salary, what kind of recommendation you could give? You could tell number one, what? Increase your experience because it's a significant predictor. Number two, increase your marks. That means increase your knowledge. Experience and knowledge. Marks are again, knowledge. Increase the knowledge. So the marks will be high. And it will translate into higher. But third one, are you encouraging to get a membership? Would you encourage them to get a membership in ACS as it was in this case? No. Why not? Because it's not significant. So except the first two independent variables, the membership does not have a significant impact. So we cannot provide a recommendation to get membership to increase salary. Right? You can say in the SPSS regression output, in the SPSS regression output, in the SPSS regression output, SPSS regression output, comma. The coefficient table indicates, that experience and aptitude marks have a significant positive impact on their salary. First of all, however, possession of a membership does not indicate a significant impact. First of all, therefore, based on these results, therefore,
come up based on these results, we could recommend that. We could recommend that. We could recommend that. In order to increase, we could recommend that. In order to increase the computer programmers' salaries, they should obtain more experience, and more knowledge, Okay. So that's how once you do a regression analysis, you come into the conclusion. Now then you can provide recommendation. So that's as researchers, as policymakers, as regulators, that's the practical implication. It's not just doing some regression analysis and giving you a result. You have to make policy recommendations. You have to make what? Policy recommendations. Right. Did we do a regression analysis based on total life such stress age? Did you do that? No. I think then high time that give you the chance to do regression analysis by your own and then interpret the results. Probably after that, I'll ask you to come forward and elaborate what's unfair and then. No, I'm going to wait. But today is Saturday evening and hospitals are usually understaffed. And doctors have left this country, majority. There's an exodus. Could be Galle, right? Train. Doctors are leaving. And what these doctors are doing over that country? Just check what they are doing. You'll be surprised what they are doing. Some doctors, not all. They have very good jobs here and what they are doing there. I'm not discouraging anyone to leave this country. Of course, go with qualifications, go with a plan. Just don't go because others are. First have a good plan and a good destination. I know some people who went to UK and my God, they did not have a plan. They thought, okay, going to UK itself is the plan. Now they're suffering. They don't even have to. He went with his family. He's a utter fool. Right? He went with his two kids and his wife. And now he's suffering there. He cannot sustain his family. The salary is not enough. The compensation is not enough. And it's damn cold there. And they are huge. They had very good jobs. It was a bad management. Now living in a kind of a slum-like place, and they cannot even pay for heating that. They cannot pay for the cost for the heat. This all everything. Even the vehicle there. So therefore, what I'm telling is, please go, please see the world. But again, have a plan. Don't because of others going. Don't just try to waste your life. Have a proper plan, a destination, and go there and get it. I know another software engineer. He was a software engineer that earned a very good salary. But it was again. So I wrote his wife. That's why I know that. I wrote his wife a recommendation that saying that she's very good in studies in English. She was, and they looked at later, and he also went on the spot. And he thought that he will be able to get a job as software engineer or even more higher in Canada. But now what is he? He's driving Uber. Thanks. With all due respect to those people, I'm not demeaning anyone. Uber taxi is excellent. I'm here because of that today. You will find it station. Right? I'm not telling anything about that, but see what he has done to, and then now immediately they come.
back here, because people will find out. But he's unable to find, because why? Ego. He was a computer software engineer. Now he's driving people. He's a people taxi. It is not disrespect. He's the Uber taxi driving and after sanitation. There is no problem. That's very respectable job. Indeed, I'm not taking his job. But what did he do for himself and his family? That's why. I'm not discouraging anyone to go to any country. I, in fact, was in Japan for 5.5 years. It was a fabulous country. I got my full experience, educational and otherwise. You also get there. I'm telling you. That's no problem. There's no problem. But go with a plan. And there should be some certainty in terms of your employment, in terms of your career. Don't get deceived. Now, I know some people who went to UK, now this same person I was saying now he has nothing to do with me. What he was doing is to deceive others. He goes to parks with his family and smiles and put large photographs in his face. What happens? The other fools look at that. Let's go tomorrow. Don't get deceived with those kind of things, like, kind of photographs and a synthetic world created by Facebook in Facebook. It's a synthetic world. Just embrace hard facts, have a good plan. Of course, go and get your education. And we make global graduates safe. Get the PhD, masters, PhD, and any other qualification. We have the path to get the chartered qualification. But be very strategic. Don't get deceived because of some others audience. That's dangerous teaching. Okay. So computer programmers. We have two recommendations. What are the two recommendations? Number one, increase the experience. Number two, to increase the knowledge so that they could go more on the aptitude test. Don't say that just aptitude test marks will increase the salary. No, it translates into aptitude marks is what? It's an indicator. It's an outcome of what? Knowledge. If you have good knowledge, good experience, you can get better salary. So that's the translation. That's how you would translate this result into practical application. But on the other hand, it says the data indicates that no, the computer, any computer membership, right? Programmers membership in a computer association of this computer-related matters does not have any. Okay, right? That's it. So this is how you could take practical insights out of these analysis. Data analysis is not just statistics. It's where you take hard solutions based on past data. Then you can make recommendations. No one can challenge because it's based on data. Based on hard, collected, nice data. Okay. Any questions here? No questions? The next thing that I'm going to discuss is assumptions, which is a little bit difficult to understand, but again, I'm going to explain. But first, the easy ones. Okay. Now take down a topic, regression assumptions. Regression assumption. We'll first discuss the easy assumptions, then after we'll take a break and we'll come back and discuss the more difficult assumptions. There are six difficult assumptions, which takes time. Right. Now, first we understand straightforward assumption. Straightforward assumption number one. Variable time. This assumption of this requirement. The dependent variable, the outcome variable should be always continuous. To do an OLS regression, ordinary least squares regression, the dependent variable should be a continuous variable. What are the other types of variables? Category variables. Can gender be a dependent variable in this case for an OLS regression? Gender? You can't. It's not a continuous variable. How about salary? Now, in the early example, salary was the dependent variable, isn't it? Computer-based program salary. Is it a continuous variable? Yes. those is usually expressed in thousands of servers, and it can take any value between two values. So that's what the continuous variable. Right. Your bank account balance, let's say bank account balance, is it a continuous variable? Yes or no? Yes, it can take any value. It can take any value. 600 million. Some models are in 1 billion, they are paying, you know. One of these guys was billions of months. Likewise, you can have any more. So likewise, those are called continuous variables. But let's take, for example, having membership for no membership. Having a professional membership for no membership. Is it a continuous variable? Is it a continuous variable? No. It's a dictonomous. Having membership. Dictonomous. Dictonomous two states. Gender, is it a continuous variable? Can we have 1.1, 1.2, 1.3, 1.4 up to 2? One male, two female, let's see. Can you have any percentages or no, you can't. So it's not a continuous variable. How about revenue of a company? Revenue of a company, is it continuous or is it dictonomous or categorical? Revenue of a company? So likewise, what it says is the dependent variable in the OLS regression analysis will be always a continuous variable. So we know we write a regression equation as well. Y equals alpha plus beta 1 x1 beta 2 x2. What it says is this variable, the y variable, which is the dependent variable, should always be what? Should always be a continuous variable. Right? Understood? It should be a continuous variable. Flow programs are indicated. It's a continuous variable. It should be always a continuous variable. Not dictonomous, not a nominal. Of course, nominal cannot be there. It cannot be a dictonomous variable like dummy variable. No, it cannot be a dummy variable. It has to be always a continuous variable. But the independent variables or the predictor variables, these variables x1, x2, they can be continuous or they can be dictonomous. They can be continuous or they can be categorical. Right? They could be continuous. Now here, for example, I took what? Computer programmers experience. Experience is what? A continuous variable, because it can have any number of years. Between 2 points, between let's say 10 years and 20 years, it can have any value. So it's a continuous variable. But on the other hand, membership. Programmers membership in the computer society. Professional body, what's that? It's a dictonomous variable. Two positions are there. Dictonomous. Dictonomous again. There are two positions in a dictonomous variable. Dictonomous. Dictom is two positions. Like Galle. Galle has two positions, right? Then computer programmers professional affiliation membership. It's a dictonomous. So it can. So these could be continuous or dictonomous. That's what it says. Can be continuous or dictonomous. Dictonomous example, write down gender. Dictonomous gender. Gender is a dictonomous variable. There are two positions. Based on what I believe, right? Based on what I believe, there are two positions. For some people might be on several other kinds of genders, but again, I know about two genders, males and females. But nothing in between. Maybe there are some guys in different genders, but I don't. Right. So this is the first assumption. First assumption. So can gender be the dependent variable?
Gender equivalent dependent variable. Not allowed. Gender cannot be the dependent. Next one. Assumption number 2. Non-zero variance. What is that? Right? There must be. Non-zero variance. So let me explain that using Excel, because for the online, for the participants who are joining online, they might not see the board. So logistical arrangements, ergonomics. Okay. So let's open my other beloved package, which is Excel. What do you mean by this non-zero way? Yeah. Dixon is only 2 categories, but there might be some variables like more than 3 categories, more than 2 categories. Then we don't call it Dixon, but it's a category. Good question. She was asking whether Dixon can be taken as a category variable. Yes. Categories, 2 categories. But Dixon is only 2 categories. But there could be some variables that have more than 2 categories, like for example, religion. Religious affiliation. You have more than 2. In that case, it's a category variable, but not Dixon. Right. So let me now demonstrate what we mean by non-zero variables. After that, maybe you can, the others, you don't need much explanation, but. So let's take for an example, a situation like this. Let's say marks. Or there will be these examples for marks. Easy to confuse. Okay. Marks, and let's say number of hours. Sorry. Let's say for an example, and also I'm going to take age. So let's say marks of a student is taken as the dependent variable. And there are 2 independent variables. What are those? Number of hours studied and the age of a student, right? Now let's see a situation like this. Let's see a situation like this. Let's say these are the students. Let's say student A, B, C, D, and E. Let's say student A got 89 marks, 78 marks, then 56 marks, then 98 marks, and let's say 45 marks. The number of hours studies, let's say for an example, this student studies 120 hours, the student has 110 hours, the student studied 60 hours, this one 150 hours, the student studied 40 hours. Right? Is that clear? On the other hand, let's say the age is 25. 4. Age is 25.4. Part of 25. Can we consider age as a predictor? Can we consider the age as a predictor? We can consider a variable as a predictor variable, as an independent variable, only if it changes the other dependent variable changes. Here, although the number, now you can see number of hours. This person has studied 120 hours and got 89 marks.
While this person 110 marks will be low, so 78 marks. This person searched only 50 hours and got 56 hours, 56 marks. And here 150 hours. A significant amount of hours has been put into studying SPSS and data analytics and has got 98 marks. But on the other hand, this person has just studied 40 hours and got 45. So you can see the number of hours studies seems to have an impact on the marks. But age, does it have an impact on the marks? No. Because age is fixed. So if I ask this question from you, to take the variance of age, what's the variance of the age variable? 0. There's no variation. Variance of age is 0 because the old is 25. So therefore, what this assumption says is an independent or predictor variable should have always what? Non-zero variance. The independent variable should have what? Non-zero variance. Means in simple English, what it says what? It should not be just have the same value. If it is having the same value, then it's zero variance. No variance, no change, no difference. So the assumption is what? A predictor variable should always have what? Non-zero variance. It has to change. It has to have different values. So that's the idea. What it says is non-zero variance. Independent variables, the predictor variables must not have zero variance. Or in other words, the same value. You can take down the same value. Like the age, which at over 25, so it's not going to have a predictive value. And what will happen in SPSS, if you put this kind of variable, it will remove that variable from the analysis. SPSS එක මේ වගේ variable එකක් දාපුවම ඒක remove කරනවා. It says that this variable is invalid. It doesn't have an impact on the mark. Because it has no change. Fixed. If it has something on impact, it has to change. It has to differ. Either positively or negatively, that's a different story. But here, it has non-zero variance. So take down that example if you want. Take down this example. Age has zero variance. So this is not a predictor. Age is not a predictor because it has zero variance. You can take up this example and say age has zero variance. It doesn't change. Zero variance can change with that. Part of this party. If you put this way space, it will reject this way. It will say no, you cannot take this variable as a So this says this variable is not a good variable. There's zero. Okay. So zero variance means it doesn't change. For all observations, the same. Clear? Right. I'm going to take a small break. Next break that move. So it no point. And the point is we have both each other. Point. So let's need a 520. 5. Here.
Yeah, I got it. I understand. Thank you for that concern. That Script to statistics one thing revision is a team the revision coordination statistic coordination I'm going to just think of
I still do not mark the family love.
What are you doing?
Okay, so welcome back. What has happened to the students? Okay. So they are enjoying their leisure time. Okay, right, good. Right. So welcome back, and we shall continue our discussion. So this is where I teach you what? That there's an assumption that says what? There should be what? There cannot be zero variance variable. There should be some variation in the variable to be considered in the regression. So that was the thing that we discussed. Then linearity, of course, that's a basic assumption because we are predicting linear regression. We are predicting linear regression. We are trying to do linear regression. Very good. So batch reader is there, and let's thank for that. The both batch readers are there. Right. Linear. Now we are trying to predict linear regression. So here we are trying to predict linear regression.
between the independent and the dependent variables, not curvilinear, not hyperbolic relationships, but we are trying to see linear relationships. Linear. So that's an assumption itself. We expect that the variables have a linear relationship. But in the real world, are linear relationships? Are everything linear? Even salary and satisfaction. Is it a linear relationship? Salary by satisfaction is linear. For example, if this is salary and if this is satisfaction, what happens? When salary increases, yes, it goes up and after some point it goes down. After some time, even if you are given a higher salary, you don't get satisfied. Why is that? Money itself cannot motivate you after a certain point. You need intrinsic motivation. Intrinsic motivation. I think in HR, you might have studied that there are two kinds of motivators in a person's life. What's that? One, intrinsic motivator. The other one is extrinsic motivator. Something that motivates you from outside. For example, salary. Salary is an extrinsic motivator. Intrinsic motivators are something that comes from inside. Like for example, you don't get any monetary compensation, but let's say you got recognition. You get recognition. You have been recognized as a good employee, as an ethical employee. You might not get any pay increase, but you will be happy. You will be satisfied. So likewise, in this world, you cannot always expect linear relationships as a line. It's sometimes not the case, but in the regression analysis, we assume that there are linear relationships. Right. So this is the linearity and independence. Independence means now, for an example, all observations needs to be independent. So here A, B, C, D, E, those are 5 different students. Independent students. Can we have again A? Like, can we again A? All observations needs to be independent and coming from separate individuals. That's what the next assumption is. It has to be independent. They cannot be having 2 or 3. The same person cannot have 2 or 3 unless it's a panel structure, which I'll teach you later. So they are going to be again A. So that's what it says. All values of the outcome should be coming from a different person, not from the same person. Right? You cannot have the same person A, B, C, D, E. It has to be separate individuals. Marks from separate individuals. So that's another assumption. So these are the assumptions that are there. Then comes more tricky assumption. No multi-collinear. No homoskedastic. What's homoskedastic? Homo sapiens, we know nothing other Homo sapiens, but again, homoskedastic. Independence of errors. Normally distributed errors. What are these? That's what we are going to study from this point onwards. Seriously, we are going to see what are these. Because there are 6 assumptions, more advanced assumptions. The early assumptions were easy assumptions. Easy, yes. They are classified as easy assumptions to understand. But now I'm going to come into more advanced assumptions in regression analysis. To perform a regression analysis, an OLS regression analysis, these assumptions need to be satisfied. If not, you cannot perform OLS regression. You might need to perform some other types of regression. There are other types of regressions as well. But we stick to OLS regression, that's more than enough. But again, what are the assumptions? Let's see one by one. And I'll teach you how to test these one by one. Right. We'll use the same maybe example, right? The computer programmer's salary and the three independent variables, the two independent variables. We'll just drop off this membership, yes or no kind of question. We'll take the experience and the aptitude for test marks, and we'll try to see the impact, right? Selection. We'll do it together and we'll try to establish what are these more advanced assumptions. We'll start with multi-collinearity. What's multi-collinearity? Then heteroscale asset. Auto correlation. Yeah, what no. Those are perfectly good words, right? Statistical terms, not bad words. I never utter bad words in public or even private. So these are some good things that are there, and I'll teach you one by one. And for this, I'm going to give you another tutorial. For me, a tutorial, I'll be giving you a tutorial, and I'm going to use the tutorial to show all these things. And that tutorial itself has all the explanation. We'll take one by one and try to understand what are these. Yeah, there's session 4, good tutorial for regression checking assumptions. Can you see that? It's a PDF file. PDF file left here. And you open it. You know, it is there. I'm really thankful to the two leaders. They have sent some good information, really appreciate it. Always, you have given me information. Yeah, that's a nice now 16D. Yeah. Okay, now again. There's no need. I'm going to put it to 16D EXP for all the students. So there is one PowerPoint, not that one. And I'll put that here. Maybe on week 14, I'll put it. It's a PDF file, right? So if it's not there, I'll put it. This is and then I'll put this file over there. Right now you can, I think if it is not there, you can access it. Right? Under week 14. Trying to check week 14.
That's the thing. 14, you can go to 16D, both, I think both groups have access to that. So, package-based data is 16D EXP. Please go to that and go to week 14. Then it says good tutorial regression checking assumption. Right? Did you get it? Right. So now let's open that file. Right. Now let's see assumption 1. So please take down assumption number 1. So these are the 6 assumptions, which is one is a repetition of the earlier assumption, but again I'll be taking 6 assumptions. Assumption number 1. Assumption number 1. The IVs and DVs should have a linear relationship. What are IVs? What are DVs? IV is independent variable. Let me no, okay, very good. So please take down assumption number 1 that the IVs and DVs should have linear relationship. What are IVs? IV can independent variable. DV is the dependent state. So independent variable is a dependent variable should have a linear relationship. How can you check this assumption? You can check this assumption visually. To check this, draw a scatter plot diagram. Please take down, draw by this assumption, please take down. This assumption could be checked. This assumption could be checked by drawing scatter plot diagram. This assumption could be checked by drawing scatter plot diagram. This assumption could be checked by drawing scatter plot diagram. Shall we draw scatter plot diagrams? Did I teach you how to draw scatter plot diagrams? Yes. So we'll use the same computer programmers example, and you can draw scatter plot diagram. So what's the independent and what's the dependent variable? First one is the experience, the other one is the marks. Right? Shall we draw scatter plot diagram and see? You can go to graph, analyze. You can go to graph, legacy dialogues, and what? Scatter or dot diagram, which we studied right under correlation analysis as well. Scatter plot scatter dot diagram आपको बता देंगे. Dot diagram है. Graph, legacy dialogue, scatter. Graph, legacy dialogue, scatter. Right? Go and click on this diagram and then select what? Simple steps. Say define. And now what's the independent, what's the dependent variable? Now we'll consider first the experience and the salary. What's the independent variable? Experience. Experience is the x-axis. Then salary as the y-axis. And press OK. Experience in the x-axis, right? Then salary in the y-axis. Press OK.
What kind of relationship you can see? What kind of relationship you can see? There is a positive relationship. When the experience goes up, the salary also goes up in C. Good. That's nice. Then what's the next pair? So we have somewhat satisfied that assumption. What's that assumption? The independent and the dependent variable should have what? How can we check that? By drawing a scatter dot or scatter diagram or a scatter dot diagram. So we can say yes. The assumption is somewhat satisfied. But at least for this pair. Then let's go and draw for the next pair. What's the next pair? Marks and self. For the first pair, the assumption is satisfied. There's a linear relationship between. You can see the dots are falling in a line. That's what we call a linear relationship. So now let's draw it to the second pair because we have two independent variables. Go to graphs. Legacy dialogues. Simple scatter, define, and now it's not the experience that you have to take what the other independent variable? The marks. Take the marks and put it in the x-axis. And 7. Marks and the 7. Marks and the 7. I find it. That was where it is. And let's press OK. Take the marks, go with the marks and the salary. Press OK. They are also what you see, not that significant, it's a little bit scattered, but again, somewhat positive relationship you can see. Not a straight line indeed, but again, you can see some dots here and here as well. But again, it seems a positive relationship. So by looking at the scatter plot diagrams, you conclude that there is, in fact, a positive relationship or a linear relationship. Not a positive, it can be positive or negative. A linear relationship is there. So therefore, under assumption number 1, you could see by looking at the relevant scatter plot diagrams, the linearity is observed. The linearity is observed. So you can take down. Assumption number 1. Assumption number 1. By looking at the relevant scatter plot diagrams, by looking at the relevant scatter plot diagrams, it is observed that there is a linear relationship. There is a linear relationship. There is a linear relationship. There is a linear relationship between the independent variables. Between the independent variables. Between the independent variables. Between the independent variables. Between brackets. Between brackets. Experience and marks. Within brackets, experience and marks. Close brackets. And the dependent variable. And the dependent variable. And the dependent variable. Within brackets. Within brackets.
So you establish that there is a linear relation. There is a linear relation. So that's assumption number one. Now let's go to the tutorial and let's go to the assumption number two. Assumption number two. Assumption number two says there is no multi-coordinating in your data. Please take that. Assumption number one, there's relationship, linear relationship. Assumption number two tells there is no multi-coordinating in your data. There's no multi-coordinating in your data. Multi-coordinating. There's no multi-coordinating. There's no multi-coordinating in your data. What is multi-coordinating? What is multi-coordinating?
Is it a bad word that should not be uttered about?
No, it's a good word. Multi-coordinating means what? You know what? Multi-coordinating means unnecessarily high relationship between the independent and independent variables. But if there is unnecessarily high relationship between what? Independent variables, we call it multi-coordinating. You expect what? You expect the independent and dependent variables to have a relationship, isn't it? But do you expect a relationship, high relationship between independent and independent? No. The independent variables needs to be independent from each other. Right? Independent variables need to be independent from each other. But if there's very high correlation, very high relationship or association between the independent and independent variables, we call it multi-coordinating. Now, with the Sagan, you always could expect that the independent and the dependent variables should have a high relationship. Independent and dependent. Okay. But on the other hand, independent variables, do you expect a relationship? So, in other words, what you can say is, you expect here in x1 and x2, these are the two independent variables, with what? A high correlation, high relationship. But do you expect these two to have high correlation? Positive or negative? Independence variables has to be independent from each other. If the independent variables have high correlation, high associations, we call that the multi-coordination. So that's what we are going to say. So to check this multi-coordinating, there are two methods. Say method number one. Method number one. Calculate the correlation, calculate the correlation coefficient. Calculate the correlation coefficient. That's method number one. Between the independent variables. Between the independent variables. Here, how many independent variables are there? Two. What are the two? Experience and marks. So check the correlation. How to check the correlation? Do correlation. So shall we do the correlation analysis? Of course we do, sir. We do. How to do a correlation? You go to the regression. You go to analyze. You go to correlate. You go to bivariate. Analyze, correlate, bivariate. Analyze, correlate, bivariate. Right. And let's take the two independent variables, experience and the mark. Close the knowledge. You don't take the dependent variable, which is the salary, which we are not interested in that. We are interested in these two. Now, if you had several other independent variables, you can put all the independent variables. And later, it's a independent variables path. So you might have several independent variables. A 42. That's okay. What's the correlation? Is there a correlation between these two independent variables? Correlation is there. We need to figure out what the current is. Area is clear. Correlation is there. How can you see whether there is a correlation or not? We look at the sequence. The sequence has to be less than 0.05. Is the sequence less than 0.05? No. It's above 0.05. What's the value? It's 0.14. That means what? There's no systematic relationship. There's no systematic relationship between these two variables. Is it good? Yes, indeed. That's what we expect. Independent variables have to be independent from yes. Independent variables. Take a variable, take it away. The name came what? It was on Monday. So that's good. So you can say the correlation analysis is the correlation analysis is the correlation analysis is there is no relationship. There is no real systematic relationship. There's no real systematic relationship. There's no real systematic relationship between there's no real systematic relationship between the two independent variables. The two independent variables. Within brackets IE stands for that E. Within brackets IE experience and mark. Experience and mark. So this is related to what? Multicollinearity. Multicollinearity is after the unnecessarily high relationship between independent and independent. Now there's a criteria. Usually, if this correlation coefficient is above 0.8, right? If this correlation coefficient is above 0.8, that means a very strong correlation, positive or negative, that's a concern. So please take down. In case, please take down. In case, if the correlation coefficient is above 0.80, is above 0.80, 0.8 and 0.8. 0. You know what? 0.80. It might indicate a multicollinearity. Might indicate a multicollinearity. Which is not the case here. Which is not the case here. Right? Which is not the case here. Here there's no correlation at all. So that's the multicollinearity. So this is method 1. Now take down method 2. Method 2, BIF, well, BIF, all capital, BIF. BIF stands for variance inflation factor. BIF stands variance inflation factor. BIF. BIF stands for variance inflation factor. Please take a note. To claim there is no multipolarity. To claim there is no multipolarity. To claim that there is no multipolarity. To claim that there is no multipolarity. To claim that there is no multipolarity. The VIF value. The VIF value. The VIF value. The VIF value should be less than. Should be less than 5. Remember that, that's the threshold. The VIF value, I'm going to calculation show you. It has to be less than 5. So if what statisticians have told, the VIF value should be less than 5. Some people say even if it is less than 10, there is no problem. But stringent threshold is 5. The VIF value should be less than 5. Now let's see how to check the VIF value, how to calculate the VIF value. Do it this way. You go again to the regression analysis. Go to analyze. You go to regression and you go to the same linear regression. Analyze regression mean. Go to the same place. And of course, there will be this member done. You might have the dependent variable is salary, and the independent variables are experience and scope aptitude test. So you might have membership dummy. If you do have, take it out. The calling curve if you are doing a fresh spaces regression, there is no problem. But earlier we had got membership done. Remove them. So you should have only 2 independent variables and 1 dependent variable. What are the independent variables? Experience level and the marks. And we have the salary as the dependent variable. Right? Clear? Are calling membership pay put them money? Membership cannot be there. Because we have a kind of a regression that we are running. Now go to statistics. You know the statistics skill what they have. Go to statistics. Then there is something called collinearity diagnostics. Collinearity diagnostics. Collinearity diagnostics. Please select collinearity diagnostics. Collinearity diagnostics. Here are the collinearity diagnostics. Go there. Tick that. If it's not ticked by default, please tick them. Collinearity diagnostics. Right? Correct. Collinearity diagnostics. Then press continue. And press OK. After that, you can press in the regression OK. Shall you press OK? You get the same tables, but again, under the coefficient table, go and see. There are some additional values. It says VIF. Can you see that? The coefficient table the sig level in then there are tolerance VIF value. Can you see that? What's the VIF value? Is it above 5 or below 5? Below. Is there a multipolarity? No. So please take it out. Furthermore, under the coefficient table, under the coefficient table,
under the coefficient table. The VIF values, the VIF values, the VIF values, the VIF values are below 5. Below 5. The VIF values are below 5 for the independent variable. For the both independent variable. For the both independent variable. For the both independent variable. This also indicates there is no multi-coordinating. There is no multi-coordinating. Right? So we check two assumptions. What are the two assumptions? What are the two assumptions? Linearity and multi-coordinating. What's linearity? Independent and dependent variable should have a linear relation. And we give scatter diagrams and almost resolve some kind of linear relation. So perfect for make some kind of linear relation. The second assumption is what? Checking the multi-coordinating. Right? To do that, I told you that there are two methods to do this. What's number one? You compute the correlation coefficient. Here's the correlation coefficient. And I told you to say that there's no multi-coordinating, it has to be what? The correlation coefficient should be less than 0.8. 0.8. And in this case, is it the case? It is indicated there's no significant relation, no systematic real relationship between the independent and the dependent variable. So perfect. And also I told you there's another method to check that. What's the second method? VIF. What stands for VIF? Variance inflation factor 12. So it has to be, I told what? Less than what? Here in fact it's what? Around 1. Is there any issue? So this is assumption number. Then let's now say assumption number 3. You go to the tutorial. Please take down assumption number 3. The values of the residuals are independent. The values of the residuals are independent. Or in other words, say, right? In other words, the values of the residuals are independent. The values of the residuals are independent. In other words, come on. In other words, the observations are independent from each other. 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 What do you mean by that? First of all, let's understand what are these residuals. What are the residuals? Residuals can someone English in what again? What do you mean by English and residuals? Something that remains. Residuals. Now after we consume some coffee, coffee has become what thing? Quantity has to be. Those are residuals. Is it like yes, now what in regression analysis, what are the residuals? Okay, I will choose one diagram.
Oh, yeah. Now look at this diagram and try to understand what are these residuals. Now here, there are two variables, one independent and dependent. Let's say in this example. Here you can see hours spent on revising, how much time you spent on revising the content you start. And then the exam marks. If you revise the content, if you watch the video again, if you do exercises again, if you go through the notes again, what happens to your marks? Again and again, hours you revise, what translates to that? They translate to better marks. Of course, mark my words. The number of hours you study or revise once you do a lecture and the marks that you get. And yes, you can see that tomorrow morning. Then I'm going to test two things, two areas. What are the two areas? I'm going to check what? I'm going to ask about regression assumptions. We have no time to reverse. Okay, I'm not going to ask anything about regression. I'm going to have two areas tomorrow tested. Right? One area is descriptive studies. What's the other area? Correlation. That's all. Regression? No. Regression not being tested yet. It will be tested in some other day, but not today. And when it will be tested, we have to start the lecture at 8:30 a.m. and we'll be ending the lecture at 12:30 p.m. Not 12:30 a.m. The next 24 hours. But more than 24 hours. And so the exam will be somewhere after 10 a.m. Between 10 a.m. to 12 p.m. 12:30 p.m. Between that time. And there will be about 10 MCQ questions, that's all. 10 MCQs. They'll be deal. No. You'll be given 15 minutes and 10 MCQs related to two areas. What are the two areas? Correlations and fit. So how I'm going to test that? This is how I'm going to test it. I'm going to give you the spaces out. I'll be giving you the spaces and then I'll be asking 10 questions out. So do you need a SPSS software? I'm not going to be unreasonable like that. I know some students might not have access to a computer, but you should have access to a computer to do the exam. So at least if you have a smartphone to select the options that you think is correct. So that's how it's going to happen. So somewhere between 10 and 12:30 the exam, the MCQ test will be there. It's a classroom assessment. There will be 5 or 6 assessments like that, and I'm going to take the marks of it. But I'm announcing this because some students are joining abroad now. Those days I was announcing this, I was not announcing it at all. Now we had this assessment, we just prepared this classroom assessment. Not midterm, it's not assessment, it's classroom assessment. But again, two students indicated it's difficult for them, so we'll see some alternatives for them. Others, please attempt. At least come between 10 and 12:30, and the exam will be there for 10 to 15 minutes, and attempt it and go. You can be cozy at your homes and do it. Right. So that's going to be the exam. So number of hours you revise and the marks you get. What kind of relationship do you expect? A relationship that's linear. So that's what this. Now, if you draw a straight line, we call this the straight line, the regression equation. The regression line, the linear line, we can draw. In every control diagram, we can draw this line. So this line is known as the what? OLS regression line. Ordinary least square. Actually, what you do is you draw the line that represents most of the dots. මේ line එක බලනකොට පුළුවන් තරම් මේ dots concentrate කරලා තියෙන පරීක්ෂා. You'll take that path. But however, now this is the best path it has taken. It is called the pointless path. But still you can see some observations and this line has a difference, isn't it? Some of the observations and this line that you drew to say that there's a relationship between what? Hours spent on revising an exam score, still between this line and a real observation, there is a difference, isn't it? This difference is known as an error. And also is known as a residue. That's called residue. That's called a residue. So why don't you take down? You take down this diagram, right? You can take this diagram. Like this. You can have X and you can have Y. You can have dots like this. And you can draw a line. And between a dot and this put a straight line and say, these are residues. Or it's also known as an error. The predictive line, between the predictive line and the error, there's still what? That's a residue. There's an error. That's called residue. A difference. Because you actually expect all these dots in the straight line. If it had been a perfect prediction, all the dots should be falling on the line. But it is, there are certain dots that are away from that line. That's how things are. So that difference is known as what? A residue. That difference is known as a residue. That difference is known as a residue. So here what we are trying to do is, under the third assumption, we assume these residuals are independent from each other. These residuals are independent from each other. Each observation has a different residue. Each observation has a different residue. Because each observation is independent from itself. I'm independent, have a residual have an observation right? But it says that shows the assumption that each observation comes from an independent observation. Right? They are going to be the same student again repeated in the data set. Right? On the other hand, we can then call it that the observations need to be independent. So in other words, what it says is, in other words, what it says is, these observations should be independent. In very simple terms, what it says is, these observations should be independent. They cannot be correlated. The observations cannot correlate. You expect the independent and dependent variable to correlate. But the observations should be independent from each other. Right? They should be independent from each other. Computer programmer 1 should be independent from computer programmer 2. Observations need to be independent, or the residuals need to be independent. That's what we expect under number 3. This is also known as no autocorrelation. Right? This assumption is also known as there is no autocorrelation. 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 No autocorrelation. Autocorrelation කියන්නේ serial correlation එකක් නැහැ. ඒ කියන්නේ observation අතර correlation නැහැ. You expect what? Independent and dependent variable to be correlated. The independent variable should have an impact on the dependent variable, but observations should be independent from each other. The residuals of them should be independent from each other. If not, there's a problem. That means you cannot take from the same individual and put that in the same data set. then it's not independent. How to check this? To check this, you calculate a value for Derby-Watson value. That's what is there. To check autocorrelation or check this independence, you use this Derby-Watson value. And we can test this assumption using the Derby-Watson statistic. Right now, we can check this assumption using Derby-Watson value. Derby-Watson value. एक करना किधर है हमने? अच्छा Derby-Watson नहीं होगी. Autocorrelation कर दी. So how to calculate the Derby-Watson value? Right. It's very simple. Right. You go to regression analysis. Now I'm going to tell you how to calculate Derby-Watson. I'll tell you how to interpret the result as it. Go to regression, analyze, then go to linear regression, then go to linear. The same regression, right? And yes, you have independent and dependent variables, that's good. Then go back to statistics. Yeah, I statistics for that. Normal regression negative illa. I can statistics. What the result in the world? Derby-Watson. Derby-Watson is there. Why don't you select? Derby-Watson is there. Let's continue after that. Derby-Watson is there. Derby-Watson is there. Derby-Watson. Statistics are said here, Derby-Watson. Calling number is falling. That's something. Assumption number 2. This is assumption number 3. Then press continue. That's it, and press OK. Okay. Under module summary, now you have new statistics. For what? Yeah. Derby-Watson. Derby-Watson value is the some higher carry. How to interpret that? Now let me teach you how to interpret that. I have given a note here. Derby-Watson. Read this. Read this. I have given an assumption. Read this carefully. It says to check the next assumption, we look at the model summary box. Model summary. Here we can use the Derby-Watson statistic to test the assumption that our residuals are independent or uncorrelated. The observations are independent. This statistic can vary from 0 to 4. The statistic the minimum value is 0, the maximum value is Hawaii. Then it says, for assumption 3 to be met, we want this value closer to 2. The value is this has to be closer to 2. And but this is the problem. Any value below 1 or above 3 is a problem. Any value below 1 or above 3 is a problem. Now, what's the Derby-Watson value we got? What's the Derby-Watson value we got? 2.6. Is it below 1? Is it above 3? So, Derby-Watson value is within the range, and therefore we conclude there is no autocorrelation. So, please take down. Since the Derby-Watson value, since the Derby-Watson value 2.6,
is 2.6. Is the W Watson value 2.6 is within 1 to 3 is within 1 to 3. We conclude that we conclude that the residuals are independent. The residuals are independent. Comma, the observations are independent. The observations are independent. The observations are independent. As well as there is no autocorrelation. There is no autocorrelation. There is no autocorrelation. Other than the autocorrelate. Right. So there are analytic examples which we discuss in tomorrow. Heteroscale, etc. And we discuss that tomorrow. And these are the three examples, quite tricky examples. But again, to understand it for the key. So we meet tomorrow morning online. Even if you want to come to here, don't come. Be at home. And in the case you don't have electricity or data, you come. So therefore, good luck tomorrow, and we'll meet tomorrow, and in the have to clear session. So good night and stay safe. We'll meet.